Welcome to Math Tips and Solutions. Today we will do exercise 1.4. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. Here, before going to the solution, let us recall about the rational numbers. So, if a number is given in the decimal form and if we need to know whether it is rational, there are two conditions. It should be terminating or non-terminating and recurring. If it is not terminating, then it should be recurring. I will show you with some examples. For example, 0.375. This is terminating. That means it ends after, the division ends after some digit. And 0.25, 25, 25, etc. it is continuing. That is non-terminating. See, the same digit 25 is repeating. So this type of decimals are called recurring. Non-terminating and recurring. These two digits are repeating. So repeating, then it is called non-terminating. If these two conditions satisfy, then we call it as a rational number. And if it is non-terminating and non-recurring, then it is called irrational numbers. Before going to the question, let us discuss theorem 1.5, 1.6 and 1.7. Only keep some points in your mind that for the theorem 1.5, x be a rational number. So we know that rational number can be written in the form p by q. And here whose decimal expansion terminates. So x is a rational number and decimal expansion terminates. Then the denominator q can be written in the form 2 raised to n into 5 raised to m. This means that the denominator can be expressed in the form 2 raised to n and 5 raised to m. That means only 2 and 5 will be the factors. The denominator has only 2 and 5 as factors. That one you keep in your mind. Either 2, all the factors can be 2, or all the factors can be 5, or both 2 and 5. But only 2 and 5 will come. Only that keep in your mind. So theorem 1.6 is just the converse of theorem 1.5. It is given that if q is of the form, that means the denominator is of the form 2 raised to n into 5 raised to m, then we can say that x has a decimal expansion which terminates. Just the converse of theorem 1.5. And in theorem 1.7, it is given that if the prime factorization of q is not of the form 2 raised to n into 5 raised to m, then the decimal expansion which is non-terminating and non-recurring. That means it is irrational. That means in the denominator q, if we cannot write it as factors of 2 or 5, then it is non-terminating and non-recurring. That means it is an irrational number. That means in the denominator some other factors are coming like 3, 7, 5, 3, 7, like that. Other factors are coming. Then it is non-terminating and non-recurring. Non-terminating and non-recurring means it is a irrational number. First one, 13 by 3125. First we need to check whether there is any common factor between these two. 13 and 3125, there is no common factor. Therefore, this is in the form a by b, where a and b are coprime. And we can write it in the form p by q. Here q equals 3125. And we need to check whether we can write q in the form 2 raised to n into 5 raised to m. So factorize 3125 with 5. 5, 125, 5, 25, 5. So here we can write q in the form of, there is no 2, but it's okay, no problem. 5 comes, so the denominator q can be written in the form 2 raised to 0, we know that 2 raised to 0 equals 1. So we can write like this, 2 raised to 0 into 5 raised to 1, 2, 3, 4, 5. So the denominator comes in the form 2 raised to n into 5 raised to n. That means this expression, that means this number is terminating. Therefore, q is in the form 2 raised to n into 5 raised to m. Therefore, we can write given number is terminating. There is no problem if 2 alone comes, 5 alone comes, 2 and 5 together comes, then the number is terminating. So here there is no 2, that is why we write like this, 2 raised to 0. Next one, 17 by 8. Here also there is no common factor between 17 and 8. So it is in the form of a by b, where a and b are coprime. No common, coprime means no common factors other than 1. Therefore, we have to take the denominator 8 and factorize. So here p, this is in the form p by q and q equals 8. We have to check whether q is in the form 2 raised to, q is in the form 2 raised to n into 5 raised to m. So in all these questions, we are checking whether the denominator q in the form 2 raised to n into 5 raised to m. That means the denominator has only the factors 2 and 5. Only 2 and 5 will come, then it is terminating. If only 2 and 5 comes, then terminating. Only 2 comes also, no problem. Only 5 comes also, it is terminating. 2 and 5 also terminating. 2, 4, 2, 2, 1. So 8 can be written as 8 equals 1, 2, 3. 2 cube. 8 equals 2 cube. Here there is no 5, but no problem. If 2 alone can come, then it is terminating. If 5 alone comes, then also terminating. 2 and 5 together comes, then also terminating. We can write like this, into 5 raised to 0. We know that 5 raised to 0, any number raised to 0 equals 1. Therefore, we can write like this. Therefore, 8 is in the form 2 raised to n into 5 raised to m. Therefore, it is terminating. Question number 3, 64 by 455. Here there is no common term between 64 and 455. Therefore, this is in the form a by b. A and b are coprime. Now we are taking the denominator 455 and factorizing. We are going to check whether the denominator in the form 2 raised to n into 5 raised to m. Here we can factorize it with 5, 91, then 7, 1, 3, 13. Therefore, 455 can be written as 5 into 7 into 13. This is not in the form 2 raised to n into 5 raised to m, because here 7 and 13 come. So this is non-terminating recurring. Fourth one, 15 by 1600. Here there is a common term between 15 and 1600, that is 5. So we can cancel it with 5. 5 3s are 15, and here 3, 2, 0, 320 will come when we cancel it with 5. So now 3 by 320. This is in the form a by b, where a and b are coprime. There is no common term between 3 and 320. So first you have to check whether this is in the form of a by b. That is, whether there is any common factor between these two. Now factorize the denominator q and check whether q is in the form of 2 raised to n into 5 raised to m. If this q is in this form, then we can say it is terminating, and if it is not in this form, then it is non-terminating, repeating. Now factorize this. Factorize 320. 2, 160, 2, 80, 2, 40, 2, 20, 2, 10, 2, 5. Therefore, we can write 320 equals 1, 2, 3, 4, 5, 6. 2 raised to 6 into 5 raised to 1. Therefore, this is in the form 2 raised to n into 5 raised to m. Hence, it is terminating. So, we can write like this. Q is in the form 2 raised to n into 5 raised to m. Therefore, it is terminating. Next one, fifth one, 29 by 343. Here, 29 is a prime. So, there is no common term between these two. So, this is in the form a by b. So, we can check the denominator, whether it is in the form 2 raised to n into 5 raised to m. This one, we can do it with 7. So, check it. 7 4s are 28. Here 14 minus 8, 6. 63. 9 7s are 63. So, this will come 49. 7, 7. So, 343 we can write as 7 cube. So, this is not in the form 2 raised to n into 5 raised to m. Therefore, this is non-terminating, repeating. Hence, we can write like this. Q is not in the form 2 raised to n into 5 raised to m. Therefore, non-terminating, repeating. Next question, question number 6, 23 by 2 cube into 5 square. By looking the denominator, it is given that it is in the form 2 raised to m into 5 raised to n. No need to do anything for this question. So, you can just write the denominator is in the form 2 raised to n into 5 raised to m. Therefore, this is terminating. And there is no common factor between this 23 and 2 cube is 8 and 5 square is 25. There is no common factor. This is in the form of coprime, a by b. 7 also same like that. See, but here 7 raised to 5 comes. So, this is non-terminating, repeating. 2 and 5 is here, but 7 also comes. 7 raised to 5 also comes. So, our theorem does not exist. Therefore, this is non-terminating, repeating. Eighth one, 6 by 15. This is not in the simplest form. This is not in the form of a by b. There is a common factor, 3. So, 3 2s are 6 and 5 3s are 15. Now, 2 by 5. This is in the form of a by b, where 2 and 5 are coprime. Now, the denominator q is 5 and there is no factors, only 1 and 5. So, 5 will come. Therefore, we can write q in the form, q is in the form 5 raised to 1 into 2 raised to 0. So, this is in the form, q is in the form 5 raised to 1 into 2 raised to 0. Therefore, this is terminating. Ninth one, 35 by 50. This is also not in the form of a by b. There is common term between these two. 5 is common. 7 5s are 35 and 10 5s are 50. Now, 7 by 10 in the form of a by b, where 7 and 10 are coprime. There is no common factor between 7 and 10. Now, we have to take the denominator 10 and factorize it. 5. Therefore, 10 can be written in the form 2 into 5, which is in the form 2 raised to n into 5 raised to m. Therefore, this is in the form 2 raised to n into 5 raised to m. Hence, it is terminating. Last one, 77 by 210. This is also not in the form of a by b. We can simplify it with using 7. So, 7 into 11 is 77 and this will come 30. 30 into 7 is 210. Now we cannot simplify. There is no common term between 11 and 30. So Take the denominator and factorize. 2, 15, 3, 5. Here 3 comes in this, we can write 30 as 2 into 3 into 5. Here 3 comes in the factor, 3 comes as a factor. Therefore, this is non-terminating repeating. This we cannot write in the form 2 raised to n into 5 raised to m because 3 also comes here. Therefore, this is non-terminating repeating.